This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. Assuming you already tried u substitution and things didn't cancel out, your next step would be to recognize this is multiplication, so you want to do integration by parts. The way that I set up my paper is I draw a box, split it in two, because every time we do integration by parts, there are two integrals we're going to have to do, and I like to keep things separate and organized. So the formula is uv minus v du, where the v's are on the inside. Then I list out everything I need, u, v, du, and dv. I first start with choosing what u is, and I use limit for that. So I ask myself, are there any logarithmics? No. Are there any inverse trig? No. Are there polynomials? Yes, the x squared. So x squared is going to be my u. Then whatever's left becomes my dv. Then I like to do du first because it's easier, it's just the derivative. So 2x dx, and v is my first integral that I have to do because it's the integral of dv, which is the integral of e to the 3x minus 5 dx. So here I can do a u substitution, so that's cup. C is what I care about. I care about my u, my du, and my dx. My u is going to be what's on my inside, so 3x minus 5. Du is the derivative of that, 3 times dx. Dx is du divided by whatever you see next to dx, which is 3. U is put everything in terms of u, so we have integral of e to the u. Dx in terms of u is du divided by 3. This is a 1/3. It's a constant, so you can pull it out to the front. And then we know the antiderivative of this is e to the u, so 1/3 plus c. And then the p part stands for plug your u back in. So 1/3 e, our u is 3x minus 5 plus c, and that is our v. Now we have everything we need to plug into the formula. So we have u, which is x squared. We have v, which is this, then minus the integral of v, and then du is this, so we plug it right in here. Now this is the second integral that we have to do, so we're going to take that integral and solve it in this box. But before we do that, I like to drop everything down, so this here becomes x squared e to the 3x minus 5 divided by 3 minus, and then whatever I get for that integral plus c, because it's an indefinite integral. Now we're ready to solve this integral over here. By the way, I just moved the constant out to the front. So here's my strategy. Since I already know that whatever I get from here is going to be plugged in here, I'm going to forget about everything that I'm doing. I'm going to zoom into this box, and I'm not going to leave until I'm done. So I'm going to pretend that this was the problem that was given to me in the first place. So in other words, pretend that the video just started now. So I'm going to go about this problem as if I'm just seeing this for the first time. What would I do? The first thing that you should always try is u substitution. So we would do cup, u is what we care about, du, dx, x, u would be 3x minus 5, this would be 3 dx, this would be du divided by 3, but everything in terms of u, that would be 1/3, e to the u, then 2x, and then dx would be du divided by 3, and then you'll notice that u sub doesn't work because you still have an x in the problem, so it's not completely in terms of u, it's not canceling out, which is an issue. You could try solving for x, so you have this equation, u is equal to 3x minus 5, so u plus 5 is going to be equal to 3x. You could divide by 3, so you get u plus 5 divided by 3 is equal to x, but if you plug this in over here, that also doesn't really help. So the idea is u sub doesn't work. So then you recognize, oh wait, these are two things being multiplied together. That signals to me that I should use integration by parts. So because I'm doing integration by parts, I'm going to draw a box and I'm going to split it into two, because for every integration by part problem, we're doing two integrals. And then I write my formula, uv, v du. I just made the box bigger, but the idea is we're going to say u, v, du, dv. I'm going to choose my u with limit. I ask myself, are there any logs? No. Are there any inverse? No. Are there any polynomials? Yes. There's x. By the way, we can move this 2 out to the front. This is 2/3. So our u is x. Then whatever's left becomes our dv. Then we can find du, which is easy, just the derivative of this, which is 1 dx. And then our first integral, because we're doing integration by parts, is v. So v is equal to the integral of dv. So now we're going to go into this box and not leave until we get that answer. So here we can do a u substitution. So c is what we care about. I care about my u, my du, and my dx. U is what's going to be on my inside, 3x minus 5. Derivative of that is 3 times dx. Dx is du divided by whatever's next to dx, so that's 3. U's put everything in terms of u, so we have e to the u, and then dx in terms of u, we have that as du divided by 3. 1/3 is a constant, so we can pull that out front. Antiderivative e to the u is e to the u, so we have 1/3 e to the u plus c, and then our p parts to plug our u back in, and our u is 3x minus 5, so we have 1/3 e to the 3x minus 5 plus c, and that is our v. Now that we have everything we need for our formula, we're going to go ahead and plug those things in. So u is x, v is this, minus the integral of v again, times du, which is just dx. Now here's the second integral we have to do for this problem. So we're going to do that integral in its box. But before that, you know I like to drop things down. So this drops down to being x e to the 3x minus 5 over 3 minus whatever I get for this integral plus c, because it's an indefinite integral. So now Now, I'm going to go ahead and solve this here, and now I'm going to zoom into this box, and I'm going to stay in this box, and whatever I get here, I know I'm going to plug in here. So for this integral, I already know I can pull out the 1/3. Again, I try to do a u substitution. C is what we care about. We care about u, du, dx, and sometimes our x is going to be what's on the inside. Derivative of that is 3 times dx. Dx is du divided by what's next to dx, so that's 3. U is put everything in terms of u, so we have 1/3 e to the u. Dx in terms of u is du divided by 3. That 1/3 can go out to the front, so that becomes 1/9. Antiderivative of this is e to the u, so we have 1/9 e to the u plus c. E in cup is to plug your u back in, so we have e to the u, but u is 3x minus 5. So this is the answer to this, and so this is what we put in here. Now there's something that's really important. Do you see this 2/3 here? You don't understand that this integral is represented by this, and if this is this, and this is now this, then we're missing something. We're missing the 2/3. So really from the get-go, what I should have done and what you should do in future problems is make sure you explicitly state, okay, all of this is being multiplied by 2/3. Like so, or whatever constant you have. Now, I'm going to keep the 2/3, but I recognize that I can take out a 1/3 from both of these, and also this e to the 3x minus 5. It's going to be 1/3 e to the 3x minus 5. So to get to here, multiply by x, then to get to here, multiply by 1/3. This is all being multiplied by 2/3 plus c. 1/3 becomes 2/9. And then this here is your answer to this problem. But remember that this problem was the integral that we were trying to get the answer to. So really, this is going to go over here. So now this negative distributes, and then everything just becomes a negative. Then I recognize there's a 1/3 here and there's a 1/3 here. These both have e to the 3x minus 5, so I'm going to take out a 1/3. E to the 3x minus 5. Now to get to here, I just have to multiply by x squared, minus, so minus. Then to get to here, I have to multiply by 2/3. And this is being multiplied by x over 1/3. Now I can simplify this further. This becomes negative 2/3 x, and this becomes positive 2/9. And that is my answer to this original integral.